trickle in yet, but let's go ahead and get started. Does that sound good? So welcome, folks. This is the Kubernetes Clinic on powering your infrastructure with GitOps and GitLab. You can go ahead on to the next slide here, Abubakar. We're going to start with a quick poll. Some people are still coming in, so results I'll read off where we're at. But tell us where you are in your Kubernetes journey so we know how to tailor this. We do ask this every time if you've been a repeat attendee, but just trying to have a good feeling for where folks are at for who's attending this. So that poll should be up on your screen right now. We'll give it a few seconds and then close that, and I'll read you the results. Historically, we're finding that the vast majority of people even attending these and our other events are pretty early in their Kubernetes journey. They're just getting started, starting to fiddle with things. So, all right, we can go on, and I'll wait for Dave's going to collate those results in the background and send them to me. And let's see. Oh yeah, already trickling in. Looks like about 3/4 of you are still learning. About 1/4 of you are running Kubernetes in production. So that's gives us some feeling there. So, Abubakar, you want to introduce yourself as the speaker today? Then I'll introduce myself.
Yeah, sure. Thank you. I'm Abubakar Siddiq Ango. I'm originally from Nigeria, but moved to the Netherlands recently. I've spent most of my career in community development, organizing meetups, and training and mentoring other members of the community, especially in sub-Saharan Africa. But since last year, I've moved to a full-fledged DevOps role, DevRel role at GitLab, helping the developer evangelism team work better and faster, and also evangelizing with focus in the cloud native ecosystem, Kubernetes, and so on. I'm also a certified Kubernetes administrator. Thank you. Over to you, Kendall.
Nice, yeah. Well, and thanks for being with us for this today, Abubakar. I appreciate it. I'm Kendall, so I'm president at Fairwinds, which we'll tell you a little bit about in just a minute. But I was the first hire here, so I've been involved in the Kubernetes landscape for a while. We've been Kubernetes only as a company for about 4.5 years, which was a little too early to the market. Kubernetes was just getting started when we pivoted that direction as a company. But yeah, I've been involved in just about every role in a company that's focused on Kubernetes, except for hands-on keyboard engineer. I just haven't written meaningful code in a very long time. So when I dig into the YAML, everything gets messy. But you can go on to the next slide. So real quick about Kubernetes, or about Fairwinds, and then I'll turn it over to Abubakar. Fairwinds is a Kubernetes enablement company. So we offer enablement platform things all around that. So we have services. Hand us your infrastructure, we'll make your infrastructure problem go away. That's usually smaller to mid-sized businesses that are willing to, or not willing to, interested in giving over the entire ownership of their infrastructure. So we run 24/7 pager on the infrastructure, make sure everything's up, build you a Kubernetes infrastructure that's customized to your needs. That's our core service. It's a managed service, long-term partnership is what we're looking for there. We also have a whole bunch of open source in this space because we manage so many Kubernetes clusters at scale. We see a lot of what the macro problems are in the Kubernetes ecosystem, and we often write open source projects, that help us do our jobs better internally on the managed service side, but are also relevant to the community. And then finally, we do have a SaaS offering called Fairwinds Insights that does policy-driven configuration validation. Basically, so many people out there are running Kubernetes, but it's a new paradigm. It's complicated. It's hard to know if what you're doing right. And that's where Fairwinds Insights sits. It runs on your cluster, reveals to you all kinds of things from security, efficiency, and reliability. Fix this, here's how, change this, optimize that. And then it also has policy pieces, so you can write custom policy to enforce what gets deployed into your Kubernetes clusters across an organization. That's who Fairwinds is, but today's less about Fairwinds and more about GitLab. And so, Abubakar, I'll go ahead and turn over to you, and you can dive into your talk for the day.
Thank you very much. Yeah, hi everyone. Today I'll be talking about how you can use GitOps with GitLab to power infrastructure. First, about GitLab. GitLab is an all-in-one platform for your DevOps needs, right from you coming up with an idea straight to production and monitoring. We have quite a lot of solutions that you as a company can only maintain one bill, one invoice for all your DevOps lifecycle. Now, like introduced earlier, I'm a developer evangelism program manager at GitLab. Most people ask me, what do you do in that role? It's like, okay, we have developer evangelism team members who focus on evangelism. My job is basically to make sure they are able to do their jobs right, handle all the metrics and everything for them so they can talk more and get more customers for GitLab. Yeah, today I'll be talking mainly about GitOps and how you can, what is it? Why do you need it? How you can use GitOps, and show you a bit demo of how you can achieve GitOps with GitLab. Now, first, with the what? Just like DevOps, most people who are new to DevOps think it's some tool or some combination of tools for you to get things done. But DevOps is a culture. It's a practice where you define how you do your development, how you do your operations, and how everything works together. The same thing with GitOps, but this time, you are using the tools you use in your normal day-to-day development for managing your infrastructure. The first is everyone knows, or almost everyone is getting to know that now with tools like Terraform, Ansible, Chef, you can write your infrastructure as code, right from provisioning all your infrastructure to configuring them with the right services and everything that is necessary, which is infrastructure as code, as already done by Terraform and the rest. But what happens when new changes need to be made to your infrastructure? They get made, mistakes happen. How do you revert back to the old state of your infrastructure? How do you see the growth of your infrastructure, the different versions that happened along the way? That's where Git comes in. Git allows you to use the normal tools you are used to for writing your code. You write the way your infrastructure would be. That's desired state. Then you use normal tools that we are used to in version control, which includes, we call it merge request, MR. GitHub calls it pull request. You write your code, make changes to your infrastructure as code, submit your merge request for code reviews within your team. It's always a good idea, even if you are the boss, for someone else to review the changes you are making for second opinion or any other thing. So once you do that, then comes in CICD. CICD helps you to be able to test the changes you've made. For example, with Terraform, we have Terraform plan, where you first see, okay, what are the changes that are going to happen? Or a dry run for Ansible. You see all the necessary changes that are going to happen, what's going to be removed, what's going to be added, and what if, in case there is any destructive action that's going to be performed, you are aware before any changes is made. Then you move to continuous deployment or delivery. Continuous deployment is where as soon as all tests passed, it just deploys or executes whatever it needs to do. But delivery is where you have to go in, check, okay, even if the test has passed, you still want to do it manually to make sure nothing bad goes wrong. So that's where all the different components that we are already used to comes together to make GitOps.
Well, I mean, I want to interrupt you there and ask you a question about that. So, like, you said everybody thinks DevOps is this like tool, right, when they're new to it, but it's actually a silver bullet that's going to make all your problems go away, right? But I mean, it is best practices around that, and then GitOps is just another best practice. It's taking an existing DevOps best practice, which is infrastructure as code, and then creating a new process for that within Git, right? I mean, instead of, I think that some companies, well, first of all, I think a lot of companies find basic DevOps ideas outside their reach. Like it looks great on paper, but they can't get there. But then, GitOps is this next level where, okay, we've got infrastructure as code, maybe, but then once we deployed that, we clicked some things in a GUI, and now our infrastructure as code doesn't match what's actually going on in our infrastructure, right?
Yeah.
And that's what this is seeking to solve, is that problem, right?
Yeah, exactly. In infrastructure as code, the code you've written for your infrastructure is like the desired state you want your infrastructure to be. But most times anything can happen, especially with Kubernetes. Some pod might have gotten destroyed, or some things might have happened. Now your actual state is no longer matching to infrastructure desired state. So with GitOps, it allows you to always maintain that desired state in your live production environment.
And that's important because if the entire infrastructure goes down and what you have in your repo doesn't match it, then standing it back up or fixing something or reverting something or whatever, all those pieces in between, you're in trouble, right?
Yeah, exactly. Yeah. And one of the beautiful things about GitOps and the direction the industry is moving towards, it's no longer you waiting for things to happen before you fix it. It's now moving towards the infrastructure itself, the GitOps process itself should be able to recognize when something has happened, then pulls the desired state and makes the correction, sometimes even without necessarily triggering a pager duty for you to come and fix things, but just to let you know that, okay, this happened and this is how it has been fixed.
Yep. Sounds good.
Now,
thank you.
Okay, thank you. Now, next thing is, how does GitOps compare to infrastructure as code? Or almost everything now is going to code. Your configuration as code, your infrastructure itself as code, almost anything, even to the extent of we now have service providers that allows you to deploy infrastructure, metal infrastructure, where you have the physical devices. You don't have to go to the store to buy the devices yourself or order on Amazon. It's just for you to write some code and it will be deployed in one way or the other. Now, GitOps uses infrastructure or everything as code with the necessary best practice like we've defined earlier to make sure your infrastructure is up to date almost every time. And if you want automated, like I explained when Kendall was asking the question, you can move to a continuous deployment strategy where it's not any time a fault happens in your infrastructure that you will have to come and fix it. But when anytime an issue occurs, processes can be on ground to fix things. And I'll explain later where the pull strategy that most people are shifting towards. Most times our CICD is still using the push environment where strategy where you write your code, you have your CI runner, you push your code, your CI runner runs it, and it deploys. The CI runner or whatever CI tool you're using the code has to be pushed to it for it to do anything it needs to do. That has a lot of security challenges and problems, especially for people who work behind a NAT or have some security requirements. With the new GitOps process that is happening now, the pull strategy is used. The runner or whatever CI that is handling your CI/CD is sitting within your infrastructure and constantly monitors any change that has happened. It pulls the new updates, the new manifest for the new changes, and it implements it. It can also do status checks and other health checks within your infrastructure to actually determine if the desired state has changed in any way. And it pulls changes or pulls whatever new updates that is required to fix the problem. So that's the major difference between what GitOps is and what infrastructure as code is. Now, basically, GitOps is infrastructure as code done right. Now, let's move to the why. Why exactly do you need GitOps itself? First, the first component of GitOps, which is everything as code, let me just put it that way, is you get the benefit of being able to version your infrastructure or your application, and you can work collaboratively within your team. You can have a team who basically works on your application developers writes their code within Git, here GitLab. Your infrastructure or platform teams also use the same GitLab to review any new changes and anything happening within the company. And everyone can collaborate within the team and see what are the new updates coming in. Your developers are not ignorant of how the infrastructure has been deployed because they've seen it in the Git repository. Then next thing, which is part of the benefits you get with version control, is the mean time to resolve is much more shorter because you already have everything documented. You can easily roll back when an update that was pushed causes a problem. You can easily roll back or revert whatever commit that was done that messed things up. So, and the fact that you have different versions of your application, you can easily know which version was working and which one version is failing, and roll forward or backward as necessary.
Yeah. The rollback, roll forward, and it's all tied into the self-documented environment. Like if the reason that's significant, right? Somebody makes a change, it's in your infrastructure as code.
Yeah.
If they had made the change in a GUI and it wasn't documented, then when something goes wrong, you don't know what was changed, especially if somebody else changed it and I'm on pager when something goes wrong, versus it all being in code. I can see, hey, this problem started because Abubakar pushed this thing last night at 3 o'clock, and I can just roll back even though I don't know what he did exactly. And yeah,
exactly.
Right. I'm interrupting you, but it's
yeah, no problem. It's previously, my previous role in GitLab was a support engineer, and I remember being on a 6 hours call with a customer that had an issue and triggered an emergency around 6 p.m. on a Sunday evening. It's because they made some changes to the infrastructure and he wasn't privy of those changes that were made. And at the end of the day, things were broken. He couldn't also fix it on time because he's not too familiar. He was running some backup configuration, and that backup configuration deletes the infrastructure, then restores it back, any infrastructure there, and restores it back. So he kept pressing the up key on his terminal. So he ended up retrying the backup process even before it has ended. So if you are using GitOps, he doesn't have to worry or concern himself about, okay, what exactly is happening. The first thing he will check is, okay, which update was done? And immediately he can revert back. Now, the next thing is automation. As developers and DevOps engineers and infrastructure, almost everyone in tech loves to automate almost anything. There was a meme I saw earlier that, okay, you want to do something, you spend 5 minutes on it, you notice, okay, I can automate this. You spend the next 1 hour trying to automate something you will have probably done within 5 minutes. It's because we all love automation and believe, okay, next time I don't have to do it manually since I've automated it. Same thing with GitOps here. You can make sure, like I mentioned earlier, anytime any change or any new development, maybe you are bumping up to a newer version, or there are certain security challenges that have occurred. For example, GitLab provides the functionality of you being able to detect within your project if a secret has been leaked. It can be for any reason, probably someone forgot and pushed their .env, or some form of secret is exposed in one way. There's this integration with, if it's an AWS key, there's this integration with AWS where it can automatically trigger a change of those keys if it has detected, oh, this is an AWS key and it has been exposed. Who knows who has access to it? So that way you can add more automation, make sure your environment moves faster and you can run different compliance requirements against your infrastructure. Now, next thing is security. One thing that, though it's becoming lesser recently, but one thing that's a major issue, especially when you are using GitOps, is privilege escalation. Does this particular developer have access to the environment he needs to work with? Does he have access to the canary environment? Does he have access to the production environment? Probably someone gets fired and he feels like, okay, I think I need to nuke the infrastructure of this company, and he decides to go make changes in the production repo. That's going to be disastrous. So using GitOps with version control allows you to set up, this person can only make changes to the repo. He cannot push. He can do tests, but he cannot push to production. It's only this set of people that can deploy, that's continuous deployment, that can deploy to live environment. This set of people can only make changes, but they need someone else to approve or review it before it even goes to testing, not talk of production.
And this is actually too, we've seen a lot of traction in our software at this stage, because being able to, if anybody can SSH into any box in your infrastructure and make changes, you have all kinds of problems happening real quick. But if the entire infrastructure is managed as code and what can be deployed into the infrastructure is all gated by Git, then you can set permissions and policy and all of that all the way down at the code level, so that it's not deployed into the infrastructure before you find out there's a problem. You find out there's a problem back in the, before it's even admitted. And, you have to have this in order to get to that.
Yeah, exactly. You need to. And there's also this feature in GitLab environment where you can box certain branches into specific environments. Anytime any developer, because most of the developers want to test what they've done. So let's say, for example, you have a test branch. Anytime any commit is done to the test branch, it's restricted to the test environment. So, and probably you already have some Kubernetes clusters or some test environment already fixed to that test environment. It's easy for them to build. And there's another environment that you've set that, okay, anytime someone merges to the staging, so this is the infrastructure to use, and these are the set of individuals that need to be able to approve or confirm that that should proceed. Then you can have, like Kendall mentioned, a production area that needs more security. Even if you require the CTO should be the last person to hit the button for it to deploy, you can make sure for it to even get merged, probably an engineering manager has to review it and make sure, okay, everything is fine. It gets merged. After getting merged, another person probably needs to, okay, deploy, so that there's several levels of checks and balances, because in most companies, even if mistakes are bound to happen and it's part of the learning process, but being able to manage those mistakes and not allow it escalate is one of the responsibilities of any company using any form of infrastructure, not to talk of GitOps. Now, the next thing is the how. First, this is how a normal conventional CI/CD pipeline looks like with GitLab. First, you create an issue. That's the idea stage. You have some feature you want to implement. You create a merge request. And you can set the merge request. Okay, once this is done, it should automatically close this issue. Once this merge request is merged, it means it has resolved this issue. You make your commit, the commits appear under the merge. CI runs any necessary tests that is required. Then there's a review stage. A review stage is where you have something like a Terraform plan that gives you a report of every change that's going to be made. Or if you're using Ansible, it gives a long report of all the necessary changes that will occur in your infrastructure. Then you proceed to where peer review and discussion. Within the merge request, you can add a comment and set it that all discussions within the merge request must be resolved before it's allowed to merge. That way, if there's any pending issues, the merge request will not be allowed to merge. And you must make sure once every comment that is included has been resolved, everyone is notified. Okay, these are the changes that have been made by email or by Slack integration. Approval comes in, then the continuous deployment takes up and deploys to production. Now, for GitOps is not just you committing any code, it's you working with things like Terraform, Ansible, or Cisco, or any type of environment that you are using. It can also be Kubernetes YAML files where you've, or some Helm charts that where you've defined the entirety of your infrastructure. For example, like GitLab itself, I once worked with, we were speaking with Kendall earlier about visits to Prague. The customer I went to see in Prague was a customer that was using GitLab to maintain GitLab. More like they have the Helm charts that configures GitLab and everything necessary. Then anytime they make changes in GitLab to that particular Helm chart and they push, they already have scripts that will automatically convert to Kubernetes YAML files and deploy any new updates to their live GitLab environment. It's more like they are running the GitLab on Kubernetes itself. So new changes come in, new pods get deployed while they are still using GitLab. It's a nice way to be able to manage your infrastructure. Even GitLab itself can be managed with GitOps to make sure you know every single change that is occurring and every single issue that is happening. Now, not just making changes, of course. When you get to the review app, you want to make sure the change you've made, probably a new version is out. You don't just want to push it out straight for everyone within the company and break everyone's work. You want to make sure everything is fine. You want to make sure everything is running the way it should before it goes out. So that is where the review app comes in within GitLab, where you test everything, you make sure your infrastructure is fine within the test environment before you now move to deploy into production. And anytime any new change occurs, GitLab also has this monitoring feature where probably you've noticed where your nodes are not able to handle the kind of load they are being thrown at. It should automatically, through the reporting functionality within GitLab, create an issue. Okay, you probably need to add more nodes to your Kubernetes cluster, or you need nodes with much more memory, or you need to change your request configuration within your Kubernetes cluster so that more nodes can get allocated and not keep some waiting. More pods can get allocated to nodes and not keep some waiting. Once the issue is automatically created and probably triggers Slack that, okay, we have an issue on our Kubernetes cluster that needs someone's attention. Someone comes on, okay, let me edit the Helm chart and Kubernetes configuration, allow more requests to come in, or with Terraform, create more nodes and make them connect to the Kubernetes cluster, etc. The changes get pushed and you are able to stay ahead of any new changes or any new issues that are happening within your infrastructure. Now, the next thing is, earlier I mentioned that I would talk more deep into the new strategy of using CICD, especially with GitOps. The number one we are used to with GitLab CI and almost all other CI providers is the push strategy when using CI. That's where your CI runner is connected to your GitLab instance. And anytime you make changes to your code, it's pushed to the runner to execute. And most times the runner might probably be in a different environment and more information are being transferred over the internet. There might be firewall, of course, definitely, but it will be more secure, especially when you are doing GitOps, where instead of your code having to push your Git server, having to push any new changes to your GitLab runner, your GitLab runner is already within your infrastructure, probably as a pod within Kubernetes. It now pulls your GitLab server. Okay, are there any new changes that has occurred? Then it pulls those changes. This is a very good use case for people that host their infrastructure on premise and have several layers of firewalls or NAT and don't want to expose they are runners, because runners have access to a lot of credentials and a lot of other things. They don't want to risk the potential of exposing anything. So instead, it stays behind their firewall, then pulls the Git instance, the GitLab server. Okay, any new changes has occurred? Okay, fine, let me pull them. That is one. Then it goes further, because when any new changes occurs, your code is now built and is pushed to probably your Docker Hub registry or any other registry you use, or maybe in the case of GitLab, we have the GitLab registry, which is still part of the GitLab instance. It's only when you want to deploy to production that those changes are pulled from the GitLab repo. But you can also take it further, that both your live environment and the production you're pushing to, and the process, whether with Canonical or with Docker itself, that builds your images and push them to the repository, are all behind the firewall. So it's not just your production environment. Your registry also is behind the firewall, and they pull any new changes that have occurred. So your CI mainly now will be doing the testing. So once all the testing is done and everything is correct, the image builder will pull the changes, build it, and push it to your registry, while the CI runner will pull the changes also and deploy them to your production environment. Now, to make this work for GitLab, we created Kubernetes Agent based on the GitOps engine that Weaveworks has created. And what it basically does is to stay within your Kubernetes cluster, integrate with the GitLab server, and pulls real-time for changes from your GitLab server. Anytime any new changes occur, it executes them within it. If you see from the image here, you have the developer pushes his code to the application repository, which then updates the repository manifest. Then the Kubernetes agent is within your cluster and watching for any changes that are coming in. So as soon as there are changes, it pulls them and applies the changes. So that's—
And does it, Abubakar, when it applies those changes, does it apply them as a pull request in GitLab, or how does it apply them?
No, it's—
You mean it pulls what's in GitLab and applies it to the infrastructure?
Yeah, it pulls what is in GitLab. That's it's doing your continuous deployment stage for you.
For you, yeah. So anytime you make a change in the infrastructure, it's automatically updated in the—
Yeah, exactly.
Yeah. Sorry, keep going.
Yeah, hold on. So that's how it works. And any other, it goes further to make sure that, depending on your configuration, it's not just waiting for changes to happen from a GitLab repository. It also checks if anything has occurred within your infrastructure. Okay, maybe for some reason, some ports are constantly failing. Even after trying to spin up new ports, anytime the old ones fail, they keep failing. It can pull and make sure it gets the latest changes from your application repository and apply those changes within your Kubernetes cluster. Now, yeah, that will be all for all the explanations and the introductory parts. Now I'll proceed to showing you a demo of how you can use GitHub for your infrastructure with GitLab. Now, this is a layout of the demo I'll be sharing with you. I'll also be sharing the link to the source code for it so that you can preview all the different scripts that are used and how you can use them. So now the environment we have here has the infrastructure team, which is here. You have the application developers. Then you have your other stakeholders, the CEOs and others. So when the infrastructure team makes changes or add any new infrastructure, they use something like Terraform. This example is using Terraform, makes the change gets applied to your infrastructure. This example has code for the EKS, GKE, and AKS environment, then application developers can make changes. We have example codes here with Ruby, Spring, Python, and so on. Deploy their applications with Helm is get deployed to the same set of clusters. Now, one of the beautiful things that GitLab provides is you being able to integrate your Kubernetes cluster. We have support for EKS, we have support for GKE. You can even integrate right from within GitLab itself. And if you are using AKS, we also provide documentation on how you can integrate manually your AKS cluster. Once you've done that, we have this functionality called Auto DevOps. Now, Auto DevOps is where we use cloud native build packs to detect anytime you push your application, or probably you are creating a new project, it automatically detects what language is that application written in. Is it Ruby? Is it Java? Is it anyone? Then it automatically builds. You don't need to write your own CI configuration. It does everything right from push to deployment for you. It builds the application, it runs all the necessary testing it needs to run for you, then deploys. So just like Heroku, but now you are taking advantage of that kind of easy functionality within your infrastructure. GitLab provides that, and that's an example that was used in this demo. So I'll be showing you a video of my colleague who showing you exactly how this works. Then I'll be sharing a link to the resources that were used. Okay, let me stop sharing and switch. Yeah, the trick I used earlier is what I had to resort to now.
It's all part of the fun. It's all part of the fun.
Yeah. Share.
There we go. We got it.
Yep.
Today we're going to talk about GitOps, specifically how GitLab enables GitOps, and how you can use GitOps to deploy infrastructure as code. So what is GitOps? GitOps is the use of a Git repository as the single source of truth for all infrastructure and application deployment code. As you can see from my example here, we've got various different teams that contribute to code that will live in a Git repository, and then be through automation using Terraform to deploy out to different public cloud services. In this example, I'm going to walk you through how we create 3 different Kubernetes clusters in 3 different public clouds, all using a common process, collaborating with my team, all within GitLab. So first thing I'm going to do is go to GitLab and log into my group called GitOps Demo. I'm looking at the README section here, and I just want to show off kind of the structure of the group. So at the top, we have a top-level group called GitOps Demo. We've got a couple of various different individual projects and 2 subgroups, one for applications and one for infrastructure. Today, we're going to look at the infrastructure. I'm now in my infrastructure group. I've got a repository for each cloud that I'd like to work on, and one for templates. If I click on my AWS repository as an example, I can see all the files associated here. These are all written in Terraform. And I've got a GitLab CI.yaml file. This provides the instructions for the automation. Let's have a quick look around. I've got a couple of different files here, a backend file that calls out that we're going to store our Terraform state files in Terraform Cloud, in an organization called GitOps Demo, and a workspace called AWS. This keeps our running state in the cloud provider, so anybody can access this at any time. Well, anybody on my team at least. I've got another Terraform file here for the Kubernetes cluster itself, leveraging the EKS module. I give it a few parameters, like what kind of subnets, how many nodes I want, what size, and some tags. I need to create a GitLab admin user on the Kubernetes cluster. I want that done automatically as code and managed by Terraform. So I leverage the Kubernetes provider to do this. And lastly, I want to register this Kubernetes cluster with GitLab. So I'm going to use the GitLab provider to create a group cluster called AWS cluster. Give it a domain name and an environment scope, and pass in the credentials. So after this runs, all of this will be deployed. My cluster will be created in AWS, and it will be automatically registered to my GitOps demo/apps group. Let's take a quick look at that. Here I have my applications. Here I have my EKS cluster. All the information is provided automatically to GitLab through Terraform. The URL that was automatically created, the cluster name, the CA certificate, and the token. Now, to deploy applications to this cluster, all I need to do is run my CI jobs in my various different application groups. Show an example of this. I can see here that the build test. I can see that my build stage, all of my testing stage, including my security scans, and then my deploy into production was successful. If I look at the logs here, I can see the last time this one was deployed, it was actually deployed to the AKS cluster. Let's take a look at the CI code that deploys these Kubernetes clusters with Terraform. Go back to my infrastructure group, look at my templates, and look at my Terraform template. What I've got here is a CI file that has a few different stages: validate, plan, apply, and destroy. It's going to use HashiCorp's Terraform base image container. And we're going to run a few different tasks. We're going to initialize Terraform. We're going to validate that everything's correct. We're going to follow good practices, GitOps practices, by creating a merge request. That merge request will define what's going to happen. The plan file will then be uploaded to the merge request. We'll do a final plan before deploying to, after deploying to master, and then we'll apply this. We've even got a destroy stage if we wanted to delete all of this code. That's it. This is how you use Terraform to deploy infrastructure as code with GitLab using GitOps processes. Thank you.
Yeah, sorry, I can hear you.
No problem. That was good. Thanks for doing it.
Awesome. If you, okay.
Yep.
You were
Are
saying?
you all wrapped up
Yeah.
at the end? Okay. You wanna pull back up the slides and I'll finish the last few there, or do you want me to pull them up?
Yeah, let me grab the slide. Awesome. Share. Yeah, sure. Now, for those that might want to experiment and see the source code that has been used for this particular demo, you can access it in this group, GitLab group that I've created. All the repos for both the infrastructure, the application, and a detailed description of how you can experiment with it is here. Now, also, if you want to learn more about how GitLab works awesomely well with GitOps, you can check our solutions page and learn more about the different components and how GitLab can allow you to use GitOps.
All right.
Thank you.
Thanks, Abubakar. And let's see. Here, I can just share screen for the last couple of slides here. If that's okay, you can stop.
Stop sharing.
And let me pull this up. Oops, I hit the wrong button in Google Slides a lot where I say share instead of present because it seems like the right button. Yeah, right. Okay, so just to wrap up here, a couple things. We have one more upcoming Kubernetes clinic this year with INGW. So we'll be joined by the CTO of INGW for that. Well, let's see. I'm moving this window around and it's getting confusing. If you're curious in participating in one, you can get a hold of Dave. His email address is here. And then finally, we do have a Kubernetes assessment. If you're interested in going and finding out how you're doing, where you are, we have a maturity model around Kubernetes. Also welcome to go kick the tires with any of our tools or software that's out there. So thanks so much for being here. And Abubakar, I appreciate the time. We'll wrap up here. So thanks, folks.
Thank you.